Hello and welcome to IEEE Soft Robotics Podcast. In this podcast, we're going to interview researchers from both academia and industry about their work, thoughts, spectrum, and more beyond that. This is Marwa Edwini, and I hope you will find this podcast useful. If you would like to connect with us, simply send us, and we will be happy to hear from you. And here is my interview. Thanks. Hello and welcome to IEEE Soft Robotics Podcast. Hello, Jana and Shuhei for the podcast. Such an honor to have both of you. I would like to ask you first how you would like to define both of yourself for the audience who may be first time listening to you. Okay.
Hi, Marwa. Thank you for this invitation. So I'm, as you said, I'm Damian. I am a faculty member at the University of Sheffield in the Department of Automatic Control and Systems Engineering. And I also lead a group, the Sheffield Biomedical Robotics Laboratory, where we develop medical and surgical robots with a focus on in vivo and implantable robots for local therapies inside the body.
Mm-hmm. Great. Shuhei, right?
Mm-hmm. My name is Shuhei Miyashita. I'm a lecturer, a faculty member of the same department, Automatic Control and Systems Engineering at the University of Sheffield. And I lead another robotics group called Sheffield Micro Robotics Group, where I conduct a series of researches on self-assembling robots, robots that can self-assemble themselves and from parts to higher dimensional structures, or origami robots that can self-fold from sheets to complex structures to execute some tasks at an unreachable site.
Mm-hmm. Wonderful. Yeah. So since both of you were PhD student at Professor Rolf Perfer, and I think that's something was interesting to see if both of you have the same vision when you're PhD student about embodied intelligence, since this series is talking about embodied intelligence. So I'm curious, sources experience you had, and now you work in soft robotic as well. So how do you see embodied intelligence? If someone was actually embodied intelligence when it comes to soft robotics, do you have the same vision? And maybe if you can tell us first, what do you think about embodied intelligence?
Then maybe I can start. Let's say, according to DARPA, intelligence can be defined with four characteristics or capabilities. One is perception, one is reasoning, one is abstraction, the one is learning. Embodied intelligence bridges something that are defined as a classical sense of intelligence to something spatial, temporal, also constraints that we experience as time constraint or spatial constraint. So embodiment gives a rationale or the context how we associate this high-level intelligence to a real physical world.
Mm-hmm. That's interesting. Yeah.
Embodied intelligence.
The intelligence seems to reside in the body itself and not just in the central nervous system. This is especially an important point for roboticists or for those that design physical systems. It can work in our advantage, how we distribute intelligence in the materials, in structures, in mechanisms, and not just in the controller, because obviously this can help us to outsource that intelligence in a distributed way.
Mm-hmm. I think this was interesting because we asked the question, should we invest more in the brain or the body? When it comes to robotics and material we have to invest more in the brain. If you look what we have already in nature, but sometimes we have this kind of intelligence maybe in the brain. And this is a debate about where intelligence is or consciousness. And sometimes we have creatures who don't have a brain and exhibit intelligence through their bodies. So how do you see the investment? Do you think we have to maybe exhibit intelligence through the body or both of them at the same time? How do you see the correlation between both of them?
Yeah, well, I think that the best way is to address this in a monolithic manner. And so taking both the brain and the body at the same time, structurally, as well as how we control the two in an evolving manner. And so I think many people agree on this. From the perspective of our lab, we are more hardware oriented, and so we are looking at the intelligence rooted in the materials and mechanisms.
Yeah, unfortunately, I don't know if I care something about that.
My answer is probably neither of them, neither about the brain nor the body, but ourselves, how much we possess flexibility to make decisions ourselves. So it's a high level question, how much free will we possess, but basically the ultimate question. So what the current robots cannot do is basically to believe in some sort of values that are not necessarily objectively defined or defined in a different ways, depending on the countries, areas where one belongs to. And but other parts could be addressed sooner or later at some point, as long as we treat robots as passive entity, referring to input, referring to its internal states, looking at the lookup table that possesses insight and then conducts actions. But ultimate challenge that we robots are facing is pretty much whether we ourselves are something more than that, than entities that are something more than just acting passively or more than that. So in that sense,
are you suggesting that we need a different sort of perspective or paradigm in the way we should build the robots that is different than the brain-body paradigm?
yes, it could be a part of brain. We may find that answer by analyzing or investigating the brain architecture or brain system. Maybe yes, but it could be also in the body side that we may find the answer. But particularly, we should be aware that something we haven't really encountered as a paradigm or concept that brings passive things, objects, to become something more than a passive entities. And then that's the ultimate focus that we should think about it.
I think that's very interesting. I don't know if that's related, but we have Professor Donald Hoffman, and he said that he already spoke about whether we see the reality as this. And you mentioned at the beginning space and time, and he said space and time is doomed, and maybe there's something other than space and time. So when you say the brain and the body is something maybe beyond that, do you imagine what this looks like gut feeling? I don't know, something. I don't know if you can elaborate more, push more on that.
I'm aware of his talks. Yeah, and you speak, Shuhei, about these entities that from passive, that become object passive from active, and it seems that there could be sort of an active, a continuous transition between such non-living to living systems that depend on a certain complexity, and at a particular complexity, we can imagine things like differentiation, where things can differentiate into some kind of brain or some kind of body, but it's not necessarily a discrete definition of what is a brain and what is a body.
Yeah, you are the first one to say that in this series, but I think when you mentioned, when Dana said that from not non-living to living, because we had Professor Gus Iben from University of Amsterdam, and he said that he didn't understand how something come from no life to life, or this is something is not understandable how it happened. For you, so work, do you have any explanation how you can have something from life to life? If you just say it's maybe not the brain, not the body, something else?
How a system identifies itself detaching from the environment is surely one of the abilities that we recognize in the living systems. So emerging from passive entities that would form some sort of functional structure that can act like living systems. But when it itself detaches from the environment, it will intrinsically attain some sort of incentive to do something. And that's probably the starting point that we would see liveness in such an entity.
I think this is related also, or is in agreement with how I see that transition as some kind of entities that acquire a certain identity. So they are aware of their internal states, and are working towards satisfying some of those internal states' needs.
Yeah. So with that being said, how do you see that in soft robotics, this concept? Do you think maybe when you have a problem like this, saying that there's something maybe missing in understanding, or we don't give much attention in a certain area that we can't design what you mentioned? What's you look at?
Yeah, so that's a very nice question, actually. I recognize that there has been a lot of advancement in soft robotics, and it's still an open field with so many more applications and inventions to be made. Somehow, what I recognize is that they go along some kind of service application. So almost like building actuators, better sensors, better robots for some particular tasks, service tasks. And towards our ambition as roboticists to develop a greater intelligence from what we have already achieved, I think that these soft robots and robotics in particular are missing some homeostatic aspects, and this relates to what we have just discussed. Some kind of capabilities that give them this sort of incentive to survive. And I think this has been the push in an evolutionary manner to improve our intelligence, the need to survive, which our robots don't have. I've seen various groups working on self-healing robots or resilient robots, and I think this is kind of the first steps towards implementing those kind of homeostatic capabilities in robots.
So adding Dana's point, Dana has been working on robotic implant, a soft robot that is, let's say, forcefully embedded inside the human body and forcefully put into a context that it needs to be functional in such an extreme condition for such a long period. So for the robot, being able to cope with such a context, it itself shouldn't stand out completely as a different thing in that, or the context and environment happening in that person's human body, but somehow has to start seeking an interaction in a fruitful manner to provide fruitful benefits for both sides. And that's a starting of seeking an incentive as an individual entity, but as a part of a bigger system.
Yeah. So I would like to continue a little bit on, yeah, because he's stepping into my area. So, yeah, we build the robotic implants that need to stay inside the body for a while, could be weeks, months, or years. And so, obviously, in such cases, the safety is most important. And unlike in other applications where, let me think, maybe field robotics, if the drone breaks or the rescue robot breaks, you can immediately replace it. You cannot do the same with an implant, or you need to avoid doing that, to avoid further interventions and even the safety of patients. So I think we've seen similar problems or challenges with robots sent on planets like the Mars robot. We need to make sure that such a robot that is placed inside a difficult to access place is 100% operational for during all the time. And so we need to figure out what are the how to identify faults, how to compensate for faults. And so apart from that therapeutical interaction with the tissue, we also need to take greater care of the resilience of that implant, how it can maintain its operation all the time.
That's a very interesting point. I think I would like to skew in that regard because you mentioned resilience and redundancy, which is very important in robotics. But when it comes to achieve that, what are the level of intelligence? Because I want to stress again about that you mentioned that we don't understand what that thing could look like. But if you want to design this level of intelligence and have this kind of what you mentioned, do you think we have to incorporate living materials and let it maybe autonomously grow? But if we have to do something like that, and I don't know how we imagine reaching this point of intelligence, because yeah, I don't know to which level do you think we are designing smart or intelligent, and how do you view it as well? Or maybe what is your aspiration to achieve what you mentioned in the material? Which approach do you think we have to have it? Like neural, I don't know, artificial neurons in the material, or a combination. I'm curious about your thoughts about that. Yeah.
Mm-hmm. As roboticists, we just need to continue our pathway to advance the system to make it more intelligent, let's say, to attain slightly bit higher level of autonomy such that it can act more independently in a pretty much a given context, and that suffices. That gives a lower bound how a system should act. As for the upper bound, when we expect robots to act in the real world comes with lots of if-then rules that are defined with semantics. For example, this is a street, one-way street that you cannot go from this side to another side. So, and these semantics are quite tricky. It comes with ambiguities and it has dual definitions. And also sometimes changes its meaning over time. For example, this is a table, but as soon as I sit on this table, it can be defined as a chair. So object itself does not always have an objectively defined a clear meaning, and it's more about our belief, whether we believe and share the belief in pretty much the same way to run the society. But this semantics-based communication is also a classical problem, so-called symbol grounding problem or a frame problem in the classical AI. And then this hasn't been resolved yet. So yeah, that's another problem. So we will continue our journey to improve our system, but ultimately what we'll be waiting will stay the same. That's kind of my feeling.
Yeah. I like your point, and I think that is so far the ceiling that many people working on intelligence have experienced. My take, just to bring some diversity or variety to explaining your question, Marwa. So I think that we have taken as roboticists various approaches. One is the synthetic way, right? So we like to build things in order to understand them. And this is different than scientists who are studying already existing entities and trying to analyze them. So roboticists like the synthetic way, and I think that is also a good way because it provides some building blocks for us to really understand through model, through prediction, what are this system good at, whether and how intelligent they could be. And as an alternative option, I think also the biohybrid, because you were sort of alluding to the cells matter. I think the biohybrid approach is also an interesting one. Although the cells and the tissue itself is seen as a black box. So we just have to take some things as they are. Therefore, we cannot explain everything that system produces. Although it may have greater chances possibly to produce some form of intelligence just because it has that level of complexity and non-linearity from where interesting things can emerge.
Okay, thanks for sharing that. Yeah, but I'm just ask you about the design again. You mentioned resilience, and imagine we design this robot at open-ended environment. Suppose that we have this, we don't know how we can design a robot that could be in space uncertainty. Do you think we have to, in that case, less relying on the feedback, and how it could be adaptable as well? And if there's damages happening, for example, maybe in the brain and the body, I don't know what kind of scenario for robot design you have. But how do you imagine this kind of adaptation should happening? And also the morphology or the shape, or that's if you rely more on the body. So we know that nature is not really optimal, just adaptable. So how do you think in robotics we can design something maybe beyond what we have in nature, and how you can evolve with that as well? Yeah.
You mentioned resilient robots in open-ended environments, right? So that kind of autonomy challenge that as roboticists we are facing. What we are working on is developing those machines that have some internal states by which they can understand whether these machines are intercepting some external disturbances or their own faults. So in order to understand what could be an internal fault or a disturbance or just an event, a new event in the environment, a new uncertainty, we are working to provide some form of identity to these machines in order to discriminate these forms of events. And after being able to identify whether it is an authorized sort of action event or an unauthorized type of fault, then such machines can adaptively respond to them. So I think that brings that sort of resilience of the device. Mm-hmm. I wanted to continue also on this point to say that we are building machines that are soft and resilient. As you know, the softness of these materials have some inherent resilience, right? But we are also actively exploiting the softness, the stretchability of these machines for resilience. And so to give you a concrete example, one of our robotic implants is flexible with capabilities to extend, retract, and flex. And so that this sort of deformations are being exploited in order to actively identify and disambiguate faults, as well as to compensate for faults. And this is a very interesting way to deal and to adapt to uncertainties, which we haven't seen, say, in systems such as aircraft, which have a really strong conventional fault tolerance models, just because they are not able to reconfigure as soft robots.
One of the incentives for studying with robots is basically to understand ourselves. Definition of adaptation is strongly constrained by how we perceive the phenomena, applying our values, what kind of behaviors, outcomes are better or worse. But ultimately, the question is whether we can really objectively define good and bad. And I have a bit radical perception in that view that it's not so easy as we believe. I was talking with Dana about this issue. And for example, nobody doubts basically they live longer the better. But even this perspective is doubtful, given that probably people in 200 years would live twice as long as we live of now. So let's say they would live 180 years. And from their perspectives, people in 200 years, we only live up to, let's say, 80 years or 80 plus years. Would look so unfortunate, but we don't normally mourn, regret about the situation that we can only live 80 years, not 180 years, but we just cherish our lives. Why don't we really regret that our lifetime is half of people in future could be, or longer than people 100 years ago could live, which was around 50 years. So it's pretty much based on our belief that living up to 80 years should be defined as fortunate thing, and we proactively believe this is good and this is better, regardless of whether this is objectively validatable or not, is us. And by using robots, ultimately, I would like to know who we are. So the direction is different. Not good and bad exist a priori before we apply to robots, but using this robot and try to answer how we define good and bad ultimately is something that I'm keen.
So what you're saying is that we are already applying our biases on how we design a robot, or how we impose a value to a robot. But what you want to do is to create probably a self-emerging robot that has more objective values, and understand from such a dry objective value what a human is, or a living system is.
So far, mostly the robot designers provide fitness functions to robots and say this is better, this is worse. Deep learning has started to provide some tools that system itself could come up with self-defining such a fitness function. So that's the ultimate question, whether robot itself can develop its objective or fitness functions. But my perception is probably deep learning would enable robots to come up with, even at a primitive shape to possess such a tool, but that doesn't necessarily directly answer whether this is something that living systems appreciate.
Is there a clear methodology for roboticists to follow this path? I'm guessing that self-assembly, you see self-assembly as one. But are there some certain building blocks as a methodology for roboticists to follow in order to reach this?
Coming back to the initial point, knowing that even the longer to live, the better is questionable. My answer is it is almost impossible to define that to make a system that that enables itself to act better, because this definition of better is pretty much based on our subjective perception, which is not grounded to scientific objective facts.
Okay, well, what I want to say here is that you are more or less assuming that there is already some intelligent entity that can apply some judgment of bad or good. But I think you could go back to the simplicity of an entity that just wants to survive.
Even survive may not be a good thing in some context. So let's say, die quicker, the better. If there is a context or species that is put in this context, then basically to disappear is a better thing.
Yeah, okay, I can see what you're saying. Yeah, but at the end of the day, I think a number of generations are basically living under a similar set of values. And this is what we are sort of striving to optimize our lives. And so there is a set of constraints at this point in our evolution within which we are building such systems. Whereas you are speaking about more on an evolutionary scale, where even values themselves can vary.
So let's say, how do we define that how many years that one lives? Then that's the perfect state. So if we live 80 years or 100 years or 100 years, how long that should one really aim at to say, oh, this is optimal?
Some generations now, we are happy with the life extent that we have, and that's why this acts as a constraint for the type of systems that we want to build.
I think you made a soulful point, and I would like to stop again because Dana made a very important question to you about what could be the methodology about what you mentioned. What you mentioned actually reminded me also to Donald Hoffman episode. He said that there's correlation between the fitness payoff and objective reality. So, for example, that why humans don't have feather, for example, or we don't have any certain shape because we have certain fitnesses in the environment we're living in, and that's why you say maybe dying may be better and surviving may be worse for you. And that's, I don't know if you can maybe push again about what you mentioned at the beginning, because that's related to what this reality is. Maybe not the brain, not the body, it's something that what we discussed. And also that fitness payoff. So what we're really doing that 80 years and we may be exhausting, our fitness is exhausting, and that's why we die, for example. So this is a relationship between when we design the robot. Do you think maybe that question, how do you see the relationship between the fitness payoff of the robot and the reality, either it's intelligence, the brain, the body, or something else? Can you evolve it in something beyond what we have in constraint we have already in our lifetime?
This is an interesting question. For example, an ability to taste something more accurately or more precisely. Is this something better or worse as an ability? Is a questionable actually. Many people would answer, well, the more sophisticated tongue you would have, then you can really more enjoy what you eat and distinguish what you eat, and then cherish your life or fertilize your life better. However, from the survivor's perspective, if one cannot really eat food, tasty food in some place, surely demotivates the person to survive in that place, and she may decide to relocate the place to live, for example, where one can afford a better food that satisfies him or her. So this has been a question I'm wondering, how we define a better ability or a worse ability in an objective way. Same for similar to this color distinguishing ability, that whether the more variety of colors that one can distinguish, the better, and if whether this is true or not really depends on the social context we live, and it's not necessarily easily definable objectively. So yeah, this is something an open question, and I don't have a particular answer. But basically, trying to answer this question is something that roboticists are either consciously or unconsciously doing, and we will be moving towards the answer, despite the progress speed that we are facing. So I'm, in that sense, optimistic.
Yeah, I think that is one of the ambitions that many roboticists have, and I think it's a hard question to answer whether there is a particular way to answer it. Whether there is a recipe to come up with an objective valued robot that will answer, what is life, or what is good, or what is objectively bad. I think that's that's difficult. There might be a way. I am happy with developing those kind of robots that, under the current circumstances, they can dynamically update their fitness function and construct their current reality with possibly their own bias, because that is what explains what a human is, but in a more incremental way, and possibly in a bit more objective way. So applying logical inference, applying some sort of emotions or their own beliefs may explain some human behavior, some human tendencies towards peace, towards war, and that's part of the impact that we would like to have as roboticists, I think, on ultimately.
Thanks so much for this thoughtful point. Yeah, and maybe we can go for, maybe currently speaking, the technological blocks a limitation when it comes to design material that have this all intelligent or sensing, because we have this kind of approach, maybe how we can, yeah, we know sensing is still challenging and we have a lot of things to do, but do you think we have to design material that have this intrinsic sensing capabilities, and we don't have to like feed them with like conductive fiber, whatever element of sensing. And do you think that's something still challenging for you? How do you see this kind of sensing so that we can have this kind of sort of intelligence? And again, do you think we have to less rely on the feedback and make it more predictive so that we can anticipate this uncertainty? How do you see this kind of wish list sensing design, or maybe limitation we have already through your work? Yeah. Or maybe in the field in general, yeah.
Sensing at the low level can be progressed, just following the pathways that we have followed. So finding a better sensor, improving the ability of these sensors, and then, for example, pH sensor, let's say a pH sensor that can sense a wider range of pH acidic level or the higher resolution of acidic level. This kind of improvement are on track, and then we just continue our journey. However, if it comes to decision making referring to such a sensor input, we need to somehow give a meaning to the sensory input. Let's say a designer, and then this sensory input will be constrained by semantics that we use to interpret a phenomenon. And again, as long as we start relying on semantics, everything cannot be detached from how we perceive quite subjective perception of values or beliefs. So that would immediately encounter, well, the robot behaves as such. That is because it reflected your perception of good and bad as a designer. The question is whether a robot itself could do such a decision making and could develop such values itself is actually an open question. But through making different types of robots, we will surely come to this point and to see how we do such a intelligent decision makings in our daily lives. Could be through autonomous car driving, or could be through ingestible robots. But that's a part of the interesting part of doing robotics researches. I'm not directly answering, but yeah, that's what I'm thinking.
I think we've seen great strides in sensing and in soft sensing. And yeah, there are still technical challenges as we do need more sensing and more sensing, right? Distributed sensing is not enough just to have a sensor at the tip of an end effector, right? We want to know exactly where we have interacted, how we interacted with the environment. We want to know, the robot needs to know about itself locally and globally. So while we've come up with various technologies on sensing, we do see the need, I think, to have more sensing, distributed sensing, and that raises more technical challenges of integration and ultimately on semantics, what Shuhei has said. We have seen passive solutions of, say, self-healing, right? But we don't, at the robotics system level, we don't know exactly, or the robot doesn't know where that fault has been produced, right? So enabling the robot to know where that sensing has been intercepted, it's also important, and we'll get to a point where integration challenges will need appropriate solutions.
So since we're posing a free question, I think I would like to follow up what you said, because you're working and you both of you have really application. I think we need it in our lifetime. So, but the question about, do you think that coming back to nonlinearities in the material, what kind of material maybe you think we have to have, or maybe kind of optimum material you think you need it in your work? But the question is, when we look, for example, I like the example of the dead fish swimming upstream, and the question how the dead fish can have all that for free. They can have the geometric, maybe I don't know what's explanation, but how this kind of geometric and maybe material nonlinearities, I don't know how we can couple them so that we can have this intrinsic, for example, controlled functionality as displacement, whatever, and also have this kind of redundancy, and we don't have to rely in an external sensing or maybe, I don't know, controller. Do you believe that? I think that's come to morphological computation and either it's part of embodied intelligence. I don't know what you think about that, but do you think we should embrace this nonlinearities in the geometry, in the material, in a certain way that we can have this intrinsically controlled functionalities and also maybe have this kind of resilience automatically? Would it make sense to you or doesn't make sense? Is it necessary to have in robotics or not?
Yeah. So our lab is we are playing with materials there, and we have two dimensions the way we address the material research. One is where we want to explore, smart materials. How can intelligence be encoded into the material structures into the materials properties and structures. But the other side is more clinically oriented, where not necessarily a new material needs to be discovered, but for the sake of quick translation, we want to sort of combine biocompatible materials that are already approved clinically, such that we use them for our medical devices. But your point, it refers more to the first type of research, and I think that we do have to embrace those kind of non-linearities from the materials. We both of us are in a control department, and in our department, our colleagues, and I think the control community has a tendency to linearize the behavior of a material or of a robotic system in order to come up with controllers that are more effective in avoiding external disturbances, right? But I think that in the long term, we are excluding some interesting behavior coming from those nonlinearities. And if we hope to have some sort of emergent systems with some interesting behaviors, I think we need to exploit those kind of nonlinearities.
A robot that can think for autonomous behavior is surely something we are looking for. So in that sense, it surely sounds ideal that everything is implemented in the body, even as a material, or even with or without electronics, that enables computational ability to reason as an entity. Now, I'm more interested in replacing electronically supported computational part with physically realized reasoning components that endows the entity with abilities to think, such that it can make decisions and act autonomously. And through investigating the possibility to realize such a system, I would pursue whether I would pursue the meaning of autonomous, something that we believe is more than just reactive performances. And then that the key feature that separates between these possible entities and the entities that we regard features a bit more autonomous decisions is something probably we should particularly focus on, even realizing physically through materials, which is probably just more than making system a bit closer to those that are implemented electronic components with microcontrollers and batteries.
So are you saying that you think that there are materials or combination of materials that can implement a smarter behavior than simply responsive?
We would continue this endeavor by making, reflexes, starting with simple reflex that smart material-based robots can respond to a signal input. And then next step would be to realize some sort of memories. The next step is some sort of logical computations. The next step will be a bit higher level computations. And make things smarter and smarter such that using a non-electronic component system could behave something equivalent to those conventional robots are already capable of, but probably at a smaller scale, so different figures such that, for example, it could be biodegradable. However, ultimately, we would encounter the same problem that current robots have encountered already, that what we mean by sensible decision makings.
Okay, that's interesting. I don't know if Dana had something to add. You want to add something, right?
I'm processing in a different way what he has said, but I can see that working.
Yeah, that's very thoughtful. So I think we have, I appreciate your time, but maybe we can ask a last question. I'm curious about, through your work, do you have any something maybe you thought would work in a certain way, but through experimentation it was surprising or counterintuitive to what you already thought about? You have maybe, I don't know, through modeling or simulation, you have certain expectation for the robot to behave a certain behavior, but in reality, I don't know, wasn't surprising. You didn't expect that, counterintuitive, and just like, wow, I'd expect that. Do you have any scenario like that happen through your research work? Yeah.
Well, I'll give one example that was surprising to me, and it kind of made me think a lot. It was the first time we implanted a robot into a living animal. And that implant has stayed in the animal, in a pig, for about 2 weeks. And we knew something was possibly wrong, but we couldn't see anything, not much from our signals, not much from the imaging, X-ray. And so as the animal was okay, we waited until the last day of the experiment, and we euthanized the animal. And when we took out the robot was pretty much all broken in parts. And what was surprising to me was that you have the most durable and robust component of this whole big system, animal and robot, was the animal, not the robot. Although you would think that, hey, you put a metal, plastic, durable robot inside an animal, that's the strongest thing in that system. Yet, even if the robot was broken, the animal survived for those many weeks, and not the robot. So that made me think about how to make a robot that maintains its operation, its structural integrity, and how to make this coupling between the living system and the robot really effective over a long period of time in a medical context. And that's one of those research questions that we work on in the lab.
Thanks so much. I think that's need another episode about structural integrity, because what you mentioned also is very, very interesting story.
So our group has been developing ingestible origami robots for the retrieval of accidentally ingested ferromagnetic materials like a bottom battery. So let a patient ingests origami robot that can retrieve an accidentally ingested bottom battery is one of the goals. And we are recently trying to replace materials with other types of materials, chemistry made of chemicals such as hydrogels. And the lifetimes of these chemical-based materials tend to be much shorter than conventional materials that we have been using for, let's say, classical robotic platforms. And for example, hydrogel is more sensitive to the environment, and sometimes it's heavily affected by the humidity and tends to get broken much quicker than we expected. So for the use in the application, it is fine, but for the use in the research to be used for weeks and months, it's not necessarily reliable. And that's something that we are learning a lot these days.
Thank you. Yeah. So the last question, I would like to ask you, what could be the most important quality you have gained while being working in academia? One important quality you have to maintain. So your academic career, maybe you have gained or you have to maintain as well. What could be that, the most important quality?
That's a good question. There are a few.
For me, the most important factor to set as a research topic is whether the topic ultimately brings us to a question to understand ourselves, ultimately to answer why we are living. So any aspect that I implement in robotics researches are more or less would not stop our walking steps towards understanding who we are. And these very subtle but quite distinctive implementations in the designing platforms, experiments, researches is something that I regard very important and the highest quality that I appreciate found in my research activities.
My personal viewpoint, and looking retrospectively as well, is trying to keep my research genuine without sort of straying my research direction according to trends that come and go.
That's thanks so much. I think very, very important point. And lastly, maybe what's the best advice was given to you, and maybe was it like changing, I don't know, for your career or maybe in general, you would like to share? Yeah.
For me, living in different, let's say, countries, really gave me some sort of insight, seeing that people have so different perceptions on the same fact so differently, just because they are in different places. And then just crossing a border and encounters quite different sets of sense of values recognized as undoubtful of facts by some people, which is not by other people, really put me in a thought. How can we objectively define, something good and bad, while we ourselves perceive so differently? And again, this semantics-based reasoning communication is so unreliable that we cannot, it's nothing more than our belief that what I'm seeing here, for example, a towel. Towel is just our belief. It's just the trillions of connections molecules. Somehow we just believe this is a towel that can be shared as a concept with others. But because robots cannot do this, such a simple perception, they still struggle to fold a cloth. But we humans can do. So there is something that separates between us and the robots. And living in different places is something, an experience that provided me with an opportunity to think these questions.
Thank you.
Well, I'm going to relate this answer to your previous point on, the academic world, I guess. And it's a nice question because it just makes me think about all the many people in the past, the past years that have mentored and held me through this path and all their advices. But so let me just settle on one, I guess, which goes back to my undergrad studies. And one of my friends have told me not to be afraid of risking and stepping into, jumping into the dark, into the unknown areas. And I think that kind of was a wake call for me, and I appreciate that kind of advice because research has been all about that kind of uncertainty and dark regions that awaits for us to discover, and not being really afraid of unpredictable paths.
Thanks so much, Dana. That was very inspiring for both of you. I think you have very thoughtful conversation and ideas. I deeply appreciate your time. Such an honor to have both of you. Thank you once again. I deeply appreciate it. Thank you.
Yeah.
Thank you for having us.
Thank you.